So the first thing we talked about was what's the difference between speed and velocity. And speed only measures magnitude, where velocity will measure magnitude and direction. Scalars, which are just real numbers, are used to denote magnitude or weight, and vectors are used to denote velocity or force. And that's what we're going to be looking at, is the vectors. So right at the beginning, it's going to be a lot of note-taking and writing and just kind of getting familiar with the vocabulary of vectors and certain things that we can use vectors and how we can use them. So a vector is represented with a line with one arrow. It's called a directed line segment, like I've shown here. And it represents the direction that it's moving. It's denoted, and denoted and denote is going to be used quite a bit, and all that means is what we use to write it. So the way we write a vector is with this bold U. That should be bold, and that's the way the book does it a lot. You may see it this way with the arrow above it, or the endpoints, like here A and B, with the arrow above it. A is the initial point, B is the terminal point. You don't need to write this part. That's just kind of me saying we're going to be using it in the plane. It's the two-dimensional plane that you're used to, the XY Cartesian plane. Okay, magnitude of a vector U is denoted using like the absolute value bars, is what it looks like. Is the length of the directed line segment, and that's important. The magnitude measures the length of the directed line segment. And then here, only two vectors are equal if they have the same magnitude and the same direction. So here are some examples. I have some equal vectors here. They're same direction, same length. These vectors are not equal because although the magnitude is the same, the directions are opposite of each other. These two have the same magnitude, but different directions, and the directions aren't related. And then these two have different magnitudes. You may have to pause it to write some of it down. That's fine. Just pause it whenever you need. To do vector addition using the vectors, two vectors, U and V, can be added here together using the tail to tip or head to tail rule. Basically, you're given these two vectors here, and we can move the V, so it's the tail of V to the head of U, and the sum of U and V is the resultant vector from tail end of U to the tip end of V, meaning from here to there is the resultant vector. And so that vector is U plus V. That's what that is represented. Because vectors can be equal as long as the magnitude and the direction are the same, you can place any vector in the position vector. So position vector U here is with the initial point at the origin and the terminal point at point A, B. And that's the point that it's ending at there. So what that means, if I draw a triangle here, this length here is length B, this length here is length A. And I'm going to use this figure quite a bit in the next couple explanations. So the way to write the vector U, and let me write that a little bolder. Is equal to AB. And you use it with these little arrow bracket looking things. And the a and b are the components of vector u. So the magnitude, which is denoted using the absolute value bars, the magnitude or the norm, it can sometimes be called, of a vector AB is you use the square root of a squared plus b squared. And basically this comes from the Pythagorean theorem. You have this, remember, if I draw this figure, you have a squared plus b squared is equal to c squared, u squared in this case, and you take the square root, and that's where that formula comes from. So to do the first example, I'm going to draw it this first time. Okay, so I have the vector 3, -4. So it's going to be ending at this point here. And what that means is this is -4, this length is 3. So I can use that to find the magnitude of u. I can use that formula, square root of 3 squared plus -4 squared, and that's going to be the square root of 9 plus 16. The magnitude is the square root of 25, so the magnitude of u is 5. And what that means, the length of this vector that I've drawn is 5. Alright, for the direction angle. The direction angle is the positive angle between the x-axis, and it's really the positive x-axis here, and a position vector. So I'm looking for this angle from the positive x-axis to the position angle. So you can draw this figure again, and if I'm looking for this angle and you're given these components of the vector, what you can use is SOHCAHTOA, and in this case we're going to use tangent. So to find the direction angle, it's going to be the tangent of theta is equal to b over a, as long as a does not equal 0. So to find the direction angle of vector v here, which is -1, 5, looks like I need one more here. So I have -1, 5, it's going to be ending. I can do the tangent of theta is equal to 5 over -1. So tangent of theta is equal to -5, and if you remember when I'm missing the angle, I can use the inverse trig function. So the inverse tangent of -5 is equal to theta. Well, when you do the inverse tangent of -5, it becomes -78.7. And what that's showing you, let's first talk about the angle that I'm trying to find. The angle that I'm trying to find is this angle here. And as you can tell, that's greater than 90 degrees. But in the definition of direction angle, it has to be a positive. So what they're giving you when the calculator gives you that -78.7, they're giving you this angle here, -78.7. And so in order to find theta here, you're going to take 180 degrees, because both of these lines form a straight line here, even though it may not look like it in my drawing. So 180 degrees minus 78.7 is going to equal 101.3. And that's going to be what theta is equal to. So you have to kind of draw it out and see, depending on what quadrant the angle is, the calculator is only going to give you an angle in quadrant 1 or a negative angle that's in quadrant 4. So you may have to finagle it a little bit and figure out what the actual angle of the vector that you're trying to find is. Here's a couple you try questions that you can try on your own. You can pause it here and I'll give you the answers here in a little bit. 5 seconds. Alright, so for question 3, the answer should be square root of 26. This is the magnitude. Question 4, I've drawn the angle that I'm trying to find, and I'm trying to find this angle here, what that theta is. And to do that, tangent of theta is equal to negative 4 over 3. So inverse tangent of negative 4 over 3 is equal to theta, and that comes out to negative 53.1, but what that's giving me is this angle here. So what I need to figure out is this angle. So to do that, I'm going to take 360 and minus 53.1 in this case, and that gives me 306.9, and that's the direction angle. Okay, that's it. I'll try to have the next one up as soon as possible as well.